So we're going to do two examples. This is probably my 5th time doing this lecture, just because I forget that you can't see things because I'm not looking at my screen. So if I go too fast, just pause it. We are finding the area. So the first thing I'm going to do is I'm going to graph this parabola opening downward. I know it's opening downward, hitting at 2, and it's hitting at these 2 places here on the x-axis. I'm going to draw my second one, which is a line with a negative slope. So what you're always going to be expected to do, is draw that representative rectangle. And I can see that the height of this is always my parabola minus my line. So notice the parentheses there. I can also see no matter where I start this representative rectangle, the width of it is always a dx cut. So what we're going to do is we're going to add up all these rectangles, infinitely many of them, as my dx approaches 0. And we need to find the a value where I begin this and the b value where I start. So it looks like that happens when these two lines, this parabola and line are equal to each other. So it's where 2 minus x squared is equal to negative x. I'm going to move the x squared over and the 2 over. And the whole process here is something you learned in algebra way back when. That's really not my concern right now. My concern is helping you set up this integral, that you understand that it's height and width. So I'll leave that for you to integrate. The answer to this is 4.2. Now here's where I keep having trouble. When I am looking at this, I'm going to graph these two. And Zach, I need you to help remind me to come back so that you guys can see the gosh darn screen. If I'm graphing this cubic, and I go ahead and factor, I can see that I hit at 0, 3, and negative 2. So matching my screen, it looks like my cubic is in blue. So I'm going to hit at negative 2, 0, and 3. And my cubic kind of comes down like this, drops real low, and goes up. So the next one I'm going to graph is my parabola. And again, I can see it on Desmos. And I would expect you to use Desmos. It's somewhat of a waste of your time to do what I'm doing right now, try to find it numerically. All right, right now it is. Okay, so if I'm looking, my parabola is on the coming in here, but dipping here and out. So I see I have 2 distinct areas that I'm going to be looking at. So you can see them there. I'm going to bring up my sheet here so you can see them. So I just drew those, and I found those regions. So what I'm going to do is find the area in this first section, which is blue minus red. So I'm going to take the blue, which was my cubic, and I'm going to subtract my red. Again, notice my parentheses. And I need my limits of integration. So I can see that my little representative rectangle goes from this point right here, which I don't know, to this point of 0. So I need to find that point. And in order to do that, again, I'm going to take these, and you could also use Desmos. I'm scared to go back to that screen because I won't remember to pull it back out. And what I'm doing is I'm setting my parabola equal to my cubic. So I'm going to move this over. So I have x cubed minus 2x squared minus 3x equals 0. Looks like I could take out an x. And again, this isn't what I'm worried about you being able to do, because you could be looking at Desmos right now. But I'm on my 5th time trying to record this because I forget to go back so you can see the screen. And so those are my points. And so I can see that this is negative 1 where those intersect. So you would distribute your negative, integrate your polynomial, and then put in your limits of integration. But to that, you would have to add this second integral, or second space. And so I'm going to draw my representative rectangle. It's always, in this side, red minus blue. So my integral is red, which is my parabola, minus, I'm going to put those in parentheses, my cubic. And I can see this point was 0 where I started, and this was 3 where I ended. And again, I would integrate that, and when I was done, I would just add those 3 areas together. So it's now not about the integration component of it. It's really about how do I set up the integral so that I'm finding the area between these curves.